Dear students, welcome to the online class. I am Dr. SSC Hiramat. In this video, you are going to study about the chain reactions. Chain reaction is a reaction which takes place in the number of stages. Then one intermediate is consumed and regenerated in between these stages, or a reaction in which one of the product works as the reactant in the reaction, that is called a chain reaction. Okay, now chain reaction is a reaction which takes place in a number of steps in which active intermediate consumes, intermediates are consumed and regenerated before products are formed. That is, the reaction is completed. Now it involves the number of following steps. First one is chain initiation, where the chain starts. Second one, chain propagation, means chain is continued. Chain inhibition, which decreases the rate of the reaction or the length of the chain. Chain transfer. Then last one is chain termination, where the active intermediates are consumed. Thus it can be explained with the help of a diagram, that is concentration versus time. Concentration versus time. Suppose this is the concentration of the reactant initially. As the reaction proceeds, concentration of the reactant goes on decreasing. Concentration of reactant goes on decreasing. Suppose this is reactant. Then about the product, the concentration of the product goes on increasing, and finally it goes on decreasing, that is, goes on increasing. In this way, the more and more amount of product is formed. Suppose this is product. This shows the product and this shows the reactants. Whereas the intermediate is formed initially, then the concentration of the intermediate goes on increasing and reaches a maximum and again goes on decreasing. Like this, the intermediate, active intermediate. This is one active intermediate. The active intermediate may be also called the chain carrier, which is responsible for the continuation of the chain. Here the concentration of the reactants goes on decreasing, concentrations of the products goes on increasing, whereas the intermediate concentrations initially goes on increasing and after that it goes on decreasing. Thus here the rate of the reaction depends upon the concentration of the active intermediate. In the chain reaction, another term is used, that is steady state. One term is used. Here steady state means a stage is reached at which the concentration of the active intermediate remains constant. Okay, means the total amount of the active intermediate formed is equal to total amount of active intermediate consumed. Thus a stage in which the concentration of the active intermediate remains constant, this is called a steady state. Now to derive the rate expression, we are going to use this principle of the. Now let us study about the kinetics of chain reaction by taking an example of a reaction between hydrogen and bromine. Hydrogen reacts with bromine to give hydrogen bromide. That is, one molecule of hydrogen reacts with one molecule of bromine to give two molecules of hydrogen bromide. This is the reaction. Now this reaction takes place in the different stages, that is, it is an example of the chain reaction. First step of the chain reaction is chain initiation. That is, one molecule of bromine dissociates to give, that is, active species. this takes place with rate constant K1. Suppose this is very slow step or the rate determining step. Then second one, chain propagation. Chain propagation. Here another reactant is hydrogen. It reacts with the active intermediate, that is Br dot, and gives HBr, and another active intermediate or the chain carrier, that is hydrogen atom or the hydrogen free radical is formed. Here one product is formed. Then another molecule of the bromine reacts with this chain carrier, that is H dot, and forms another molecule of the product, and another Br dot is formed. And this reaction suppose takes place with rate constant K2, and this reaction takes place with rate constant K3. Then next one is chain inhibition. Chain inhibition. Inhibition means which slows down the reaction, because it slows down the reaction. Here one molecule of the product is involved. Suppose one molecule of the product is HBr, and it reacts with the active species H dot and forms one molecule of H2, and Br dot is formed. Suppose this is equation 4. Here we call it as the inhibition because instead of giving the product here, product is consumed in this reaction to give the reactant, that is H2. Then fourth one is chain termination. Chain termination. Termination means the active species are consumed and becomes inactive species. Here 2 Br dot, that is free radicals are the active species, combine to give Br2, and this takes place with the rate constant K5. Suppose this is K4. Here we call it as the chain termination because the chain carrier is Br dot or H dot, but here both the chain carriers are consumed and inactive Br2 molecule is formed. Therefore, this is called the chain termination. Now, in this reaction takes place as you represented. It consists of the 5 steps and the 4 stages. The chain initiation, chain propagation, chain inhibition, and chain terminations are there. Then the products are formed in these 2 reactions. Products are formed in these 2 reactions, and one product is consumed in these reactions. Okay. Thus, the rate of the reaction may be represented as rate of the reaction is represented by the change in concentration of the one of the product, that is the product. Rate of the reaction is equal to d HBr divided by dt, because HBr is one product, hydrogen bromide is formed. Okay, HBr is one product. That is d HBr divided by dt, that is hydrogen bromide formed. Now, hydrogen bromide is formed in these 2 steps, that may be written as K2 into concentration of hydrogen and concentration of Br dot, one step. And here also the HBr is formed, plus K3 into Br2 plus into H dot, that is intermediate H dot of the active species. Means by these two reactions HBr is formed, and by the chain inhibition step, that is for third reaction, this is consumed. Means minus K4 into concentration of HBr, concentration of HBr into concentration of H dot. In this way, rate of the reaction may be represented by this, because our product is HBr. Here the reaction, the product is formed by these two reactions and it is consumed by this. Suppose this is equation 1. Now let us apply the steady state to the intermediates. There are two intermediates, one is Br dot and another is H dot. It is applying steady state, applying steady state to chain carrier, we may call it as the chain carrier, Br dot. It may be represented as d Br dot divided by dt is equal to, that is change in concentration of, or the rate of change of concentration of Br dot with respect to time. Here Br dot is formed by the first reaction, that is K1 into concentration of Br2, concentration of Br2. By this reaction Br dot is formed, and next one is in the second equation Br dot is absorbed, that is K2 into concentration of H2 into concentration of Br dot. Here Br dot is absorbed, and even in this reaction Br dot is formed. You may take it as the plus, that is equal to K3 into concentration of H dot into concentration of Br2, concentration of Br2 H dot. Here the Br2 is formed, plus, you may take plus, here Br dot is formed, that is plus HBr, that is K4 into HBr plus H dot. Here the Br dot is formed by this reaction, K4 into concentration of HBr into concentration of H dot. Then in the last equation Br dots are consumed, and that too with, that is K5 into concentration of Br dot square. This is equal to 0, because we are applying here the steady state. Change in concentration of Br dot with respect to time, this is equal to 0. Suppose this is equation 2. Similarly, we may apply the steady state to the H dot also. H dot is also one intermediate here. H dot is also intermediate. Then d of H dot divided by dt, d of H dot divided by dt, that is equal to, H dot is formed by this step, that is K2 into concentration of Br dot into concentration of H2. Here the H2 is used, and H dot is consumed in this reaction, minus K3 into Br2 into concentration of H dot. Here the H dot is consumed. Okay, H dot is consumed in this reaction, Br2 and H dot. And here also H dot is consumed, minus K4 into HBr into H dot, concentration of H dot. This is taken as equal to 0. Suppose this is equation 3. By equation 3, there is no change in the concentration of H dot is represented. Here H dot is represented, there is formed by equation 2, consumed by equation 3, and again consumed by equation 3. In this way, this is consumed. Now, from these two equations, for the simplification of this is equal to 0, this is equal to 0, means 0 plus 0 gives 0. Therefore, equation 2 plus equation 3. Equation 2 plus equation 3. What do we get? Equation 2 plus means K1 Br2. K1 Br2. Okay. Then K2 H2 Br dot, K2 H2 Br dot, one is minus and another is plus, they get cancelled. Then K3 H dot Br2, K3 H dot Br2, these also get cancelled, one is plus and minus. Then K4 HBr H dot, K4 HBr H dot, these also gets cancelled because one is positive sign and another is negative sign. Then only remaining term is minus K5 Br dot square, and 0 plus 0, that is also 0. That is also 0. Then we may rearrange this to get Br dot. That is Br dot is equal to, concentration of Br dot is equal to, now let us take this side, then K1 Br2, K1 Br2, concentration of Br2 divided by K5, that is K5. Okay, that is totally, this is equal to 1 by 2. That is equal to square root of K1 by K5, K1 by K5 into Br2. Suppose this is equation 4. Now, from equation 3, now let us keep as it is. Let us take it on the right hand side, and we can make it equal to H dot concentration. That is, concentration of H dot is equal to K2 Br dot into H2 divided by, minus becomes plus, H are taken common this side, then you will get K3 divided by K3 Br2 plus K4 HBr. This is equal to concentration of H dot. This is equation 5. From equation 4 and 5, now you substitute the value of Br dot from equation 4 in the equation 5. Then you are going to get H dot is equal to K2 as it is, then square root of K1 into Br2 divided by K5, then H2 divided by K3 Br2 plus K4 HBr. This is equal to square root of K2 square root of K1 by K5, then H2 into square root of Br2 divided by K3 Br2 plus K4 Br dot. K4 Br dot. K4 HBr. K4 HBr. Six. From equation 3, this is equal to 0 means this part is equal to this part. That is K2 Br dot into H2 minus K3 Br2 H dot is equal to, this is equal to K4 HBr into H dot, concentration of H dot. Suppose this is equation 7. Now from equation 1 and 7, equation 1, that is K2 K3 Br2. From equation 1 and 7, we will get this K4 HBr H dot equal to K4 HBr H dot. We may substitute this for this, then this is positive and this is negative and this gets cancelled. From that you are going to get 2 HBr, that is dHBr divided by dt is equal to now from equation 6 and 8, we get, that is 8 is d HBr divided by dt, that is equal to 2 K3, write as it is. Then you substitute the value of H dot from equation 6, that is H dot equal to K2 into square root of K1 divided by K5, dot concentration of H2 square root of concentration of Br2, that is raised to half, square root of Br2 means raised to half, divided by K3 Br2 plus K4 HBr and Br2 remains as it is, that is Br2. Then totally this is equal to 2 K3 K2 root K1 root K5 then this is H2 as it is, and Br2 raised to half. Br2 means 1, Br2 raised to 3 by 2, Br2 raised to 3 by 2 divided by K3 into Br2 plus K4 into HBr may be written as dHBr divided by dt equal to 2 K2 K3 root K1 divided by root K5 into concentration of H2 into concentration of Br raised to 3 by 2 divided by K3 Br2 plus K4 HBr. The same may be written as dHBr divided by dt equal to K into H2 into concentration of Br2 raised to 3 by 2 divided by K3 Br2 plus K4 HBr, where K may be taken as the constant, that is 2